Hi, and welcome to day 6 of Trig Graphs. Today we're going to do a little bit different things without using the graph per se. We're going to work with trig identities. And we're going to work with the Pythagorean identity sine squared theta plus cosine squared theta equals 1, where theta is any real number. And I'm not sure if we really talked about this yet, but this equation comes from our unit circle. And if you remember, we have a unit circle here. We have a triangle inside. And the equation of our unit circle would be x squared plus y squared equals 1, because we're centered at the origin and my radius is 1. But remember, we were talking about this being the cosine, this being the sine, so the width is the cosine, the height is the sine. And in a right triangle, we have a squared plus b squared equals c squared. So to find the sides of my triangle, x would be cosine, so it's cosine theta squared, plus b would be my height, so that'd be my sine theta squared equals 1, because the radius is 1, and if you square it, you get 1. And when we're talking about trig identities, we actually write them when they're squared as cosine squared theta plus sine squared theta equals 1. We square the trig function, we don't square the angle. So you got to be careful. The squared goes here. So we're using this sine squared theta plus cosine squared theta equals 1. I just changed the order. It doesn't really matter. It's the same function. Where theta is any real number. Find the sine of x given that the cosine of x is equal to 3/5 for negative pi over 2 to 0. So this means I'm in quadrant 4. Okay. And if I'm using this formula, I'm just going to write it as sine theta squared plus, we know that the cosine is 3/5. So we're going to take 3/5 and square it. And we know it's got to be 1. So I can solve for sine. So sine theta squared plus 9/25 equals 1. I just squared my 3/5. So subtract the 9/25. So we'll have sine theta squared equals, well, 1 minus 9/25 is really 25/25 minus 9, so it ends up being 16 over 25. And since that sine's squared, we need to take the square root. So the sine of theta is equal to plus or minus 4/5. And we already established that we were in quadrant 4. Since we're in quadrant 4, sine has to be negative. So therefore, that's what those 3 dots stand for. Therefore, sine of theta is equal to a negative 4/5. Find the tangent of y given cosine y equals negative 5/13 for pi over 2 to pi. So 90 to 180. So I'm in quadrant 2. And we have to remember that tangent is sine over cosine. So we still need to use our Pythagorean theorem. So we're going to say sine, in this case, is y, not theta. So sine of y squared plus cosine is negative 5/13 squared equals 1. So the sine of theta squared plus, if I square that, I'll have 25/169 equals 1. Then I'm going to subtract that 25/169. So I'll have sine theta, both things squared, is going to be 144/169. Just found a common denominator. So take the square root. So that means that sine theta is equal to plus or minus 12 over 13. And in this case, since I'm in quadrant 2, sign is positive. So it's 12 over 13 because I'm in quadrant 2. Now, I need to find the tangent. Well, the tangent of theta is equal to sine over cosine. Oh, I was using y and I went back to theta. I'm sorry. Those should all be y's. Not that it really makes a difference. So the sine is 12 over 13. And the cosine, they told us, was negative 5 over 13. This gives me a complex fraction, and to get rid of it, I multiply by the common denominator, which happens to be 13 in both cases. So the tangent is going to be negative 12 over 5. Write the tangent of z in terms of cosine of z for pi equals z to, or pi is between, or z is between pi and 3 pi over 2, so that means I'm in quadrant 3. I don't have any exact values that I'm working with, so I'm just going to work with the Pythagorean identity. So it's cosine theta, or in this case it's z, squared plus sine of z squared equals 1. I need to be in terms of cosine, so that means I need to get sine alone. So subtract a cosine z squared. So that's going to go away. So I'm going to have sine squared c, or sine of z squared. And I'm going to go back to writing it with the proper notation with the cosine. Now I need to take the square root. So the square and square cancel each other out. So the sine of z is equal to plus or minus square root of 1 minus cosine squared z. Now, we said we were in quadrant 3, so in quadrant 3, sine is negative. So we're in quadrant 3. Therefore, sine z is a negative square root of 1 minus cosine squared z. Remember, tangent is sine over cosine. So I need to take what I found sine to be equal to and put it in place of sine. So the tangent of z is equal to negative square root of 1 minus cosine squared z all over cosine squared z. That is my final answer there. Next page. We're only going to do the top 2 problems and then we'll be done. So we're going to use the Pythagorean identity to do the following. Rewrite the expression cosine theta sine squared theta minus cosine theta in terms of a single trigonometric function. State the resulting identity. All right, so what this means is we need to get everything in terms of only sine or only cosine. Since sine is squared, I can rewrite it. So go back to our Pythagorean identity. And we need to get sine squared alone, so subtract the cosine squared like we did the last time. So sine squared theta is equal to 1 minus cosine squared theta. Now I need to make a substitution into that expression for sine squared theta. So I will have cosine theta times 1 minus cosine squared theta minus cosine theta. Now I just have to do regular algebra. Distribute. So it's cosine theta minus cosine squared times the cosine would be cosine cubed theta minus cosine theta. So this cosine theta crosses out with that cosine theta, so we have a negative cosine cubed theta. All right. Rewrite the expression 1 minus cosine squared theta times cosecant theta in terms of a single trigonometric function. Well, cosecant theta can only be written in terms of sine, so we're going to have to make this show this is all sine. And from the problem up above, we already know that 1 minus cosine squared theta is sine squared theta. So I can make that substitution there to sine squared theta times cosecant is 1 over sine theta. So that means that this sine will cancel out with the sine squared. So I'm just left with sine theta for my final answer. This is just the basics of dealing with the Pythagorean identity and what it can do for us. We aren't going to go too in depth, but in other courses after this one, you may go more in depth with these identities. All right, that's it.